Hello class, once again, and welcome back to our class here in ESci 123, your statics of rigid bodies. And on our previous topic, we have tackled with internal forces. And well, we are still gonna continue that chapter, the topic, and now we will be talking about shear and moment equations and diagrams. And this one will be one of the toughest topics in this course. Why? Because it's not that hard, but we will be dealing with extremely long solutions. So probably this lecture will be long as well, but I hope not because I'm tired. Char. What are these shear and moment equations and diagrams? So basically, di ba, on the previous topic, we have ang atong goal adto is we have to solve for the internal reactions of beams and shafts and whatever. Diba? Okay. Kahinumdum ta nga atong beam and then atay loadings, probably ang ana nga loading, and ang goal lang adto is to determine the internal load at this point, or whatever points in this beam. But, however, this is not enough. By only knowing the internal loadings of a single point on the beam is not enough. Because when designing a beam, it is much important na you should be able to know which is the maximum shear and maximum moment of your beam. Because mauna sila ang mag-determine kung unsay pinakadako nga i-bear nga load anang imong beam or imong structural member. So that is why it is good for you to have a diagram. And that diagram is basically, it shows how the loadings behave inside your beam. And by looking at the diagram, you can find out which point of this beam has the highest load, and probably that point is where failure will mostly occur. Okay? And diha ka mag-base sa imong design. You should look on the highest shear or moment nga load, and then by that value, you can design it further for you to be able to accommodate that load. Okay? So muna, we should create a diagram of the behavior of our shear and moment of a beam. So that is our goal for this morning. And how are we going to do that? We should create a shear and moment equation first. And later on, we can create a diagram. Okay, so let's do this. So basically, we are still gonna use the concept of the method of sections, wherein we have to cut a beam at a certain point of the beam, and we will generate equations there. Nganong equation ma atong ma-generate? Because instead of having a certain distance, a specific distance, we will always use an arbitrary location, and it is said to be a distance of x perhaps. So let's take this one first as an example, a very simple example. So we want to create a shear and moment equation and diagram of this simply supported beam. This is a shaft because it is supported by two journals, and there is a 5 kilonewtons of load that is applied at the exact center of this shaft. So basically, if you are going to look at this one and nakikita ka nga nasa tunga ang 5 kilonewtons, then obviously you can just immediately analyze that the support section A and C have equal forces. These two supports bears half the load of this one. Okay, and basically that is 2.5 and 2.5. Because when you sum this one, that will be equal to 5. And that will satisfy our summation of forces along the y. Okay? Kana lang. Take note, you can only do this one if makita nimo nga ang imong force is located at the center, at the exact center of the shaft. Pero kung dili siya, then you should do moments. Okay? Okay. So, unsa man ito buhaton ani? Well, the first step that you should do is tan-aw nimo pila ka segments ni siya. And take note, maghimo lang ka og cut kung naa siya change sa load or nag-change ang iyang moment or nag-change ang slope sa imong distributed nga load, diha lang ta magbuhat og cut. In this case, since asara man siya nag-change og load, so of course mag-cut ka diri kay and manpud na siya and makakita ka diri asara man siya change og load. Diba kay naman kay gibutang nga 5 kilonewtons of load dira. So of course, you will create a cut there. So therefore, you have 2 segments of this beam. If another example, if you have this one, so pila man ni siya kabuok nga cut. So since this one has a different behavior sa slope compared sa ani, so lahi na sila og cut. So therefore, mag-cut ka ana diri and then mag-cut ka dira kay nag-change na po na siya kay wa naman ni diri distributed loading and mag-cut pud ka dira. So you have here 1, 2, 3 and 4 segments. Okay? So take note of that. Or on the other hand, how about ning ani? Dili na siya triangular loading but this is a parabola. And this one is a concentrated nga moment. So pila ka buok ang imong segment dere? Ang imong segment dere kani and then kana. So you have 1, 2 and 3. So take note, ing ana ang imong pag-segment. But diri sa tong basic na example. Now, nag-segment na ka diha. Pag segment na pud nimo ana, magbutang na pud ka og cut. Okay? Take note, nag-segment na ka diha sa asa nag-change og load. And pag segment nimo ana, maghimo na pud ka og cut. And kana nga cut is arbitrary. Unsay pasabutan ng arbitrary? Wala ka nag-mind kung unsay distance ana niya from the left perhaps or from point A. Pero ang imo gibuhat, that is an arbitrary distance of x. So x ang imong gipangan sa distance niya. Okay? So nag-cut ka adto, nag-change og load, and then karon sa pag-cut nimo adto, maghimo na pud ka og cut to nga ana niya. And imo gi panganlan ang distance from the left point, which is point A, to that point sa imong gi-cut as x. Okay? And diha na ta mag-drawing sa atong free body diagram. And ato panganlan unag segment 1. So diha sa segment 1, mo ni atong segment 1 ha. Kana mo ni nga length. Kutob ra diha sa tugi cut. Okay. So sa imong segment 1, ato i-draw nga segment 1. This is 2.5. And this one, well, of course, I'm gonna use the sign convention. Sige, let's just call this one NA, VA, and MA. So, dira ako na siya gitawag NA, VA, ug MA. Okay. And unsay distance ani? This distance is x. Okay. So, we have to look for the values of this one. Okay. So, una ta sa NA. NA, since wala man tayo x component gapon ani, as usual, that is 0. Okay? How about for our VA? What we have to do is to sum the forces along the y, going down is equal to VA minus 2.5 kilonewtons. So therefore, your VA right here is just 2.5 kilonewtons. Okay? How about your MA? So summation of moments at point. Dili na atong A pasabutan ni hadili ang kaning A. Oh my goodness. Okay? Kaning A ako ipasabot. Summation of moments at point A. Okay, is equal to MA minus 2.5. Now, what is the moment arm of that one? That is X. Okay, so equals to 0. And your MA is basically 2.5X. Okay. So, nanate X dire. So, this is an equation. These three values we have here are equations. But this one is a constant, and this one is also a constant. Okay? And we are going to use these values later on, so I have to save them. NA equals to 0, VA is equal to 2.5, and MA is equal to 2.5x. We have to save this one, kay importante na sila. So, erase na pod ko. And then, let's proceed to the second section. Segment number 2. So, diri na punta mag-focus. Ani nga segment. And again, same sa atong segment 1, mangita na puntag asa ta magputol sa tunga aning diri nga ato gi-cut pag red o diri sa end. So, let's say nag-cut ko tira. And now, mao na pud ni ang atong X. Ang distance from point A to this point right here. Let's make a free body diagram. This is 2.5. And after 2 meters, you have a 5 kilonewton nga load. And nag-cut ka diri, and that distance is arbitrary. That is X. And again, we have sign convention, kana, kana, and kana. NB, VB, and MB. And again, we have to solve for these things. Okay? So, summation of forces along the X. No. Again, we all know that when we sum the forces along the X, your NB will be 0. How about for your VB? Summation of forces along the Y going down is equal to VB minus 2.5 plus 5 is equal to 0. Okay, naman tayo 5 kilonewtons. So, therefore, your VB is equal to negative 2.5 kilonewtons. So, don't change the sign dere. Okay? Ayaw ni i-change nga sign. Keep it that way because we are talking about equations right here. Okay, now there is a summation of moments. Summation of moments at point B. I'm going there is equal to MB minus 2.5 times distance ani X. And then plus napatay 5 times sa naman po ni. 'Di ba? Mao man ni atong moment nga gipangita. From here to here. Magkagani ha, X kay diri padong diri. Pero kaning sa 5, diri padong diri. That is X minus 2. Diba? Kay X minus 2 kay kani. Gets? Equals to 0. So therefore, MB minus 2.5X plus 5X minus 10 is equal to 0. So therefore, your MB right here is equal to 2.5x plus 5x. That is negative 2.5x plus 10. Am I right? Am I right? So, we have this equation. So mo na sa segment 1 kani silang tulo. So sa segment 2 kanya pud sila. NB is equal to 0, VB is equal to negative 2.5, and MB is equal to negative 2.5x plus 10. We already have solved for the shear and moment equations of this one. So basically, this is your shear and these are your shear equations and these two are your moment equations. So you don't have to solve the A for this one because we are not talking about normal equations. Shear equations or moment equations na ito i-focus. So take note of these equations and we will graph this one. Okay? So let's graph that one. Okay, unsa man nato ni pag-graph. So, kaya diba ang atong goal is to solve for the shear and moment equations and diagrams. Not only we are going to create equations, which is this one, we also have to create diagrams. Now, sir, question. So, kung daghan og segments, daghan sa kag equations himoon. Exactly. So, if you have 4 segments, then you should create 4 equations. If you have 5, then you should create 5 equations, and blah, blah, blah. And now, unsay gamit na ng mga x? So, ang kaning mga x na to karon, ato ni siya i-gamit later on sa ato pag-graph. Okay. Sige. So, first, arita sa shear diagram. Ang ako lang suggestion, itungod ninyo ang length sa inyong beam sa length sa inyong diagram para easy breezy. Una ta diri sa first segment. Kaya di ba mao ni atong first segment? Ito na sila pang himuog segment dira. Ito sa atong first nga segment. This is your first segment. This is your first segment. So what is the value of your shear diagram ta karon? What is the value of your shear if your x is 0? Unsay pasabot na imong x? Ang x is basically the distance from point A. So kung naka dire, mo guni atong gibuhat dire. Kung mag-assign tag value aning atong x, then it should always be from point A. Okay? Bahalag ni abot na kadira, basta always na siya from point A nga distance. Okay. So, kung mayon ko nga, what if your x is 0? We have a value of VA is equal to 2.5. Since this one is a constant value, then you can say that is a constant value of 2.5. 2.5. What is your VA if x is equal to 1? 2.5 yapon. Diba? So, ato isulti nga 2.5 yapon na. What is your VA if 2? 2.5 yapon na. Humana ta sa segment 1. Kaya diba, ang atong segment 1 is from 0, 1, 2 meters. Okay? So, basically, di ay, kani imong segment 1 from 0 x to 2. Okay? So, gamito nimo ang imong first nga shear and moment equation kung naa ka sa imong segment 1. Ang imong segment 1, diba, sa pagkat nimo kaganiha, nagsugod ka sa sinugdanan padung sa katong asa nag-change ang load. Okay? So, diha ra ka magamit ana. So, that is from 0 meters to 2 meters. And dire, 4 meters na ni siya dira. Okay? So, take note, ana. Okay. Okay? Basically, kani, that is the length of your shaft. Okay? Kani, dire, gipakita dire, kay tutura man ni siya, and 2 ni siya dire, and 2 na siya dira. Pero dire, ato na siya is 0, 1, 2, 3, 4. Okay? Wala na. So, ato ni siya draw og straight line. So, basically, kung kung constant nga value ang imong VA, then of course imong diagram horizontal na siya nga line. Okay? Pero diri start na ta from 2 to 4. From 2 to 4, we will now use segment 2. So now, sugod ta sa 2. What is the value of your shear when your x is 2? You cannot use this equation if imong gamiton kay 0 ang imong x. Because kung 0 ang imong x, diri ka nga equation. Kay 0 to 2 ni siya. Pero kung nagsugod na ka sa 2, nag-end ka og 2, nagsugod na pug kag 2, then you will use both of the equations. Okay? Greater than or equal to 2 and less than or equal to 2. So kung ano siya, okay? Ano na siya, whatever. So what is your VB if x is equal to 2? That is negative 2.5. And let's say this is negative 2.5. So niambak siya. And then constant, di ba kay constant value raman na siya? So from 2 to 4, ang value sa atong x is also negative 2.5. So therefore, it will still go that one. Okay? And this is your shear diagram. Muna tong shear diagram. Sige, how about sa atong moment diagram? Atong moment diagram na natin equation. What is the value of, sige, ato siya 1, 2, 3, 4. So 0, 1, 2, 3, 4. Diya sa atong moment diagram, sige, ato i-show nga mga values. And, di ba kung x lang na siya, we will maka-imagine ta nga straight lang ni siya nga line. Di ba? Kaya kung nakay nga ng equation, this is linear. When you say linear, straight na siya nga line. Pero kung square na siya, parabolic. Di ba? So, kung square ang imong x, parabolic. Kung wala na siya square, linear. Kung wala na siya x, then horizontal nga linear. Yan na lang. Sige. So since this one has an x na siya slope, so what is your x? What is your MA if your x is 0? So at 0, the value of your MA is also 0. How about kung 1 na siya? Ang imong value is 1 times 2.5, that is 2.5. So this one is 2.5. How about kung 2? If x is 2, then that is 5. Okay? So basically, linear, straight line. Okay? Now, niabot na tag 2. So, balhin na puntaan from 2 to 4. So, when x is 2, what will be the value? Diba? 2.5 times 2, negative 5. Negative 5 plus 10, that is still 5. Diba? Okay. Padayon ta. 3. How about kung 3? 2.5 times, negative 2.5 times 3, that is negative 2.5 times 3. So, negative 2.5 times 3 is equal to negative 7.5. So, negative 7.5 plus 10, that is 2.5. So, balik na po tag 2.5. And then, how about kung 4? So, 2.5 times 4 is 10. So, negative 10 plus 10, that is 0. Linear, and then this is your moment diagram. Okay, so ani pag-solve ang atong problem. So, makakita ka diri. Ma-observe nimo diri nga unsay pinakadako nga shear force. Unsay pinakadako nga internal shear force nga naa sa imong shaft. Ang pinakadako nga internal shear force, these are the pinakadako nga internal shear force. The sign is negligible. Okay, so either positive or negative, mao na kung asay mas dako og values niya, mao na ang imong maximum shear. Okay? Shear max is 2.5 kilonewtons. How about sa imong moment? Maximum moment is equal to ang kinatasan, of course, or kinabubaan kung naa. Maximum moment is 5 kilonewton. So these are your shear and moment equations, and these are your shear and moment diagrams. Ba? Sayon lang. Well, sayon siya kay simple raman po datong example. Pero kung daghan na ni siyang segment, then we will realize that this will be a very long problem to solve. And ano nga case, sayon pa ni siya, ano man, kay wa man tay distributed load. Ang ato ra na adiri nga load is kaning atong concentrated nga load. Sige, let's have an example of distributed load. In this example, we have here a distributed load, and this distributed load is a rectangular distributed loading. So how are you going to make a shear and moment diagram if you have this kind of loading? Sige. And you also have this concentrated nga moment of 15 kilonewton meter, which is located 1.5 meters from your left. Okay? So let's do this problem and let's solve this one. So first thing to do, what are you going to do gani una? First is ang pinaka-importante, you should account all the external forces. You should know the external forces. But in here, it is not really necessary to solve for the two external forces or the support reactions, because sa imong gamiton nga method, you are just going to cut, di ba, ang kaning atong beam, then you can just leave either kung asa ka magpili nga side, mora tong imong isolve nga support. Okay? So, in this case, kay inigkat na to, ang ato ipili kay ang left side man, so let's just solve for this unknown support reaction. Di na ta mag-solve ani. Pero kung imo ipili kay ang right nga side, then of course you have to solve for the right nga support, and dili na ka mag-solve ani left. Okay? So let's do this. And let's call this one as A and this one as B. Okay. So, first thing to do again is to sum the moments about point B. And assuming, because your A goes this way, diba? So let's just assume that your AY is positive. So AY multiplied by 3 meters, and then dito sa to distributed load minus 2 kilonewton per meter multiplied by 3 meters para ang iyang resultant force 2 times 3 meters, and multiplied by the moment arm, which is ang centroid sa atong rectangle is located at the center, that is 1.5 meters. Okay? And then, take note, we have a concentrated nga moment. So, let's include it there. Plus 15 kilonewton meter. Do we have to multiply a moment arm again? No, because this is already a moment. Okay? Kung force na siya, then you should multiply a moment arm. But since, again, this one is a moment, then you don't have to. Okay. So, answering this one, you will have an answer of negative 2 kilonewtons. What does this mean? Therefore, your AYDI is, instead of, it is supporting upwards, it is found out to be pulling this beam down. Weird, no? Okay, so anyways, so mo ni atong AY. Solve that this is negative 2 kilonewtons. This is going down. So ito na siya plus, niya ito siya ibutang going down. Okay, so now, kapila ta mag section ani. So, di ba, mag-section ta kung na ay change in loading or change in moment or change in slope sa atong mga kuan, sa atong load. So, kapila man ta mag-cut ani? Pila ka buka to segments ani? So, as you can see, constant raman ni ang atong distributed load. So, it can be considered as a single nga segment. But since there is a change of moment there is sa atong center, then we should account that one. So therefore, duha na siya ka segment. Segment 1 and segment 2. Okay? And now, di ba, after we segment that one, ato na po na siya i-cut at an arbitrary distance of x. Di ba? And we have to draw a free body diagram sa diha sa atong gikat. Okay, so what are you going to do? Of course, you should draw the free body diagram. And always don't forget sa atong support reaction kay apil na siya. And we learned that this distance is x. Okay, di ba? Nag-cut ta at an arbitrary distance of x. And we have exposed the forces right here. And applying sign convention, we knew that this one is VA and this one is MA. Okay? Now, we're going to solve this two. So how are we going to solve this one? So first, let's go to VA. Solve for VA, then we have to sum the forces along the Y, going down. Para positive ang atong VA. Then, plus 2 kilonewtons. Yan, napatay distributed. Plus, sama ni? 2 kilonewton per meter multiplied by the distance of x. So, mao ni ang length and then mao ni ang height which is 2 kilonewtons per meter. That is equal to 0. So, therefore, your VADI is just equal to negative 2x minus 2. Okay? So, this is your first equation. From your segment A to this point. Your first segment. Okay? Sige. Now, let's proceed. Ato ta sa MA. So, summation of moments about point A. Kani nga point A ha. Mao ni ato kung pasabot nga point A. Going there is equal to MA plus 2 times x, sakto? 2 multiplied by the moment arm of x, and then plus 2 kilonewtons per meter multiplied by the length para sa iyang resultant, 2 times x, and then napatay moment arm, asa ganing moment arm, tunga sa x, so x over 2. Sakto? And then, napabatay lain, 1, 2, 3. 1, 2, 3. And then, this is equal to 0. So, therefore, your MADI is equal to negative x squared minus 2x. Okay? Gets? So, yun naman siya, no? So, we're done. We are already done on our first segment. So, we found out that the equation on our first segment is sa atong shear is negative 2x minus 2. And then sa atong moment is negative x squared minus 2x. Okay, let's proceed. Direta sa atong segment number 2. So, again, maghimo na po tag arbitrary nga cut. And from here to there, that is your x. Okay, let's go. So, again, we should draw the free body diagram. Importante kay nga mag-draw ka og free body diagram kay diha ka magtan-aw sa imo pag-analyze sa pag-solve sa problem. If you solve the problem without creating a free body diagram, that is questionable. Okay? I always use that. Even though I already knew this one very well, but I am still using this one. So there is no exception for you nga dili ka magamit og free body diagram when solving problems. So, dapat naa jud ni. Okay? And then, this distance again is your x. And we'll now have exposed our forces, our internal reactions, your VA, VB, and your MB. Okay? So, have it na. And how are we going to solve this one again? So, first we have to solve for VB. So, VB, summation of forces along the y going down is equal to VB plus 2 plus 2 times x. Sakto? Again, 2 times x. And then, wala ba na? 1, 2, and 3. Ano to? Is equals to 0. So therefore, your VB is just the same as your VA, which is negative 2x minus 2. Okay? But, there is atong moment ang mag-change. Why? Sige, ato itanaw. Summation of moments about point B. Again, this is your point B. Going there is equal to MB plus 2 times x. Okay, diba? Kani nga 2 times moment arm of x plus kanina po nga 2 times x. Okay, diba? Resultant ani 2 times x multiplied by the moment arm of x over 2. Diyan, kaya naapamantay concentrated minus 15 kilonewton meter. Wala ba na? 1, 2, 3, 4. 1, 2, 3, 4. Okay, and that is equal to 0. So therefore, your MBDI dere is equal to negative x squared minus 2x plus 15. And this is your answer. So these are your shear and moment equations for this graph. And again, we have to summarize that one para natay guide. Okay. So sa segment 1, ang imong VA is equal to negative 2x minus 2. MA is equal to negative x squared minus 2x. Sa segment 2, ang imong VB is equal to negative 2x minus 2, and your MB is equal to negative x squared minus 2x plus 15. Dali ra ni kay duha ra man ka segment. But again, kung pila ka buok segment, maupon na imong number of shear and moment equations nga dapat himuon. So in this case, since duha ra man ni, so we have to create 2 pairs. Okay. So again, we have to graph this one na, and let's do this shear diagram. So, sa ganito ato buhaton, ang ato buhaton karon is 0.5 ta. 0, this is 1.5, and this is 3. So 0.5, 1, 1.5, 2, 2.53. Para yung ana lang kuntahay. And then, sige himo tag y-axis sa kuan. Again, this is from 0 to 1.5. And this is from 1.5 to 3. Asa ganyan ko aning 3, mo aning whole nga length ha. So dirita 0, 0, 0.5, 1, 1.5, 2, 2.5, 3. Kura nagikuan sa length sa beam. Okay. So from 0 to 1.5, mo ni ato gamiton nga shear and moment equation. From 1.5 to 3, mao ni atong gamiton nga shear and moment equation. Okay? Sige. So, let's assign. What is your VA if your x is equal to 0? So, kung 0 ang imong x, ang VA nimo is negative 2. So, naa siya dira. So, what if ang imong x is 0.5? That is negative 3. So, ninaog. Now, what if your x is 1? Then that is negative 4. So, of course, this is linear. Okay? Straight siya nga line. It will create a straight nga line. And then, how about kung if your x is 1.5, then that is negative 5. Okay, this one creates a straight nga line. Now, dito sa sunod. So, of course, this is still negative 2x minus 2. So, we can just say that this will proceed. Wa man siya nagtungod, uy. Okay. So, since they have the same equation, then we can say that this will continue until it reaches diri sa atong 3. Okay. So, 6, 7, and 8. So, this is negative 8, negative 7, negative 6, negative 5. Weird. Okay, so this is your shear diagram. So what is your maximum shear? That is your 8 kilonewtons. Again, i-disregard nimo ang sign kung mangita kag maximum shear. Kung asa siya mas dako, either positive or negative, ang katong higher nga value, that is your maximum shear. Okay, but in this case, your negative 8 is your maximum shear. Okay? Sige, next, dito to sa atong moment. Okay, so let's graph this one. So, what is your MA if your x is 0? That is, of course, 0. How about your MA if your x is 0.5? That is 1.25. So, it's somewhere right here. Next, if your x is 1, so negative 1 plus 2, so that is, oh no, bali. So, negative 1.25 and negative 3. How about your MA if your x is 1.5? That is 5.25, so 2, 4, 6. So, probably lapit diri. So, basically, this one will create a curve. Maging ana siya nga pagka-curve. Okay? This is not a straight line, but to make it clearer, I will just show ito yung nag-curve na siya. Ana. Okay? So, this is your first half. There is a first segment. How about there is a PCAS sa segment 2? So, kanina ato gamiton kay we are now on our second segment. But still, we are going to start at 1.5. So, plus 15. So, therefore, so now what is your moment if your x is 1.5? 9.75. So, positive ta, 2, 4, 6, 8, 9. So, probably, naabot siya diri. Pero, so as you can see, niambak siya kalit. Okay? Naman tayo concentrated ng moment. And makita na siya, ang kaning ambak, kung dirita sa moment. Sa shear, wala na siya nakitaan. And then, proceed ta. How about your your x is 2? This 7. So, diri. 2, 4, 6. Nakuntay kay, wala naman yung na-accurate. How about if your x is 2.5? That is 3.75. So somewhere right here. And then last, if your x is 3, then it goes back to 0. So basically, it will also look like this. And therefore, this is your maximum moment, and that is M max is equal to 9.75 kilonewton meter. Kano dili man kani? Kaya I think this one is only 5, pero ang kaning isa is 9. So this one is higher than your 5. So this is your maximum. So this is your shear and moment diagrams for this beam we have here. Okay? So, nga na lang. Dugay siya i-solve. Yes, because you have to create an equation and you also have to create a diagram. But if hanas na mo, then this will be easy. Okay? Let's have another example. This one is kind of tricky because you are looking at a triangular distributed loading and lisod ni siya gamay. So, let's solve this one. Well, this one is kind of easy. Siguro kay mo ingon mo nga, usa ra man siguro ka cut kay kung ano raman same raman siya slope o man siya lang external nga ay o man siya change of load diri sa atong beam. Yes, pero sige ato tan-awon. Unsa gani una buhaton ani? Since in this case sa ako lang example karon we are going to solve on the left, di lang ta sa right kay sayon sa right pero sa left lang ta. Sige, what are we going to do? Una gani, you have to solve for the support reactions. Since this one is a cantilever beam wherein it is only supported at one end and that is a fixed support. So therefore, unsa ganing gi-restrict sa atong fixed support? Naatay X, naatay Y, ug naatay moment. But since, as you can see in this case, we don't have any X reactions right here, so we can just erase your X. So, ang nabilin is kana. And let's say this is point A. So, this is your AY and your MA. Okay, so we have to solve for this one. Okay, so to solve this one, to get AY, we should sum the forces along the Y. Going up is equal to AY minus area ani nga triangle. That is 6 kilonewton per meter multiplied by 3 meters. Papatanaw man kay kani kay rectangle pa man ni, so divided by 2. Mapapatay lain nga load? Wala na tay lain nga load. That is equal to 0. So therefore, your AY right here is equal to, so 9 kilonewtons. How about the MA? We also have to solve for the MA because this is also a support reaction. It supports the moment of this cantilever beam. Kaya kung wala kay MA, kitsa may nagkuha na ng iyang pag-turning. Okay, di ba? So, let's solve for MA. Summation of moments about point A going there is equal to MA minus kani 6 times 3 times 0.5 nya moment arm kay kani kay mao pa maning force, diba? So moment arm pila man, diba? 1/3 from here, so that is 1 is equal to 0. So therefore your MA is equal to 18 divided by 2, 9 gihapon. 9 kilonewton meter. Okay, so we already have solved for AY and MA. And we will gonna use it later. So again, next step is imutan-aon kung pila ka segments ang imong makreate sa atong beam. But in this case, di ba, ang atong criteria kung mag-ingon ta nga segment na siya kay mo-end siya diha sa na-change of loading or change of moment or na-concentrated or mag-change ang slope. But in this case, na ba change sa slope dere or na-change sa loading or na-change sa moment? Wala. Because we only have a single nga triangle and wala man tay rectangle diha nga niko nagpakita or wa man tay concentrated nga force or concentrated nga moment. So this one is only one segment. So since one segment raman, so atong equation ani is also a pair of shear and moment equation. Ana lang, ba? Sana all ana lang pag-solve. Pero daghan man tag mga changes of load sa atong mga assessment ug exam. So now, unsa gani sunod na to buhaton? Mag-cut ta diha sa atong tunga sa segment and ato ibutang nga arbitrary distance of x. And next thing is we have to create a free body diagram ana nga segment. And this is the challenging part na. Sign convention, going down and going counterclockwise. So this is your, let's say, VA and MA. Again, this distance is X. So, ang challenge ani, na dire. Okay. Una ta sa pag-solve for VA. Let's create a shear equation sa atong VA. Sige. To solve for VA, all we have to do is to sum the forces along the Y. And going down is positive. So, that is VA. Next, minus 9 kilonewtons plus, okay, nadiri ang challenge. Kung saan na ito pagkuha sa area ani? Di ba? Pwede naman na ito buhaton nga. Ato i-divide og 2. Rectangle ang isa, nya triangle ang isa. Di ba? So, ato ni tawagon nga mao ni ang first, mao ni second. Ato kuhaon ang area sa triangle. How to get the area of the triangle right here? Sige. Unsa na to pagkibaw sa height ani? Kibaw ta sa length, the length is x, right? But how about the height? Is it tricky for you? Then, di ba, we all know, balik tayo nga triangle. So, balik tayo diha nga triangle. And we know that the length of this triangle is 3 meters. And the height of this triangle is 6 kilonewton per meter. But since we cut it right here, and then we give this distance as x, and we have this triangle right here, so we are now looking for this height. But we knew that this little triangle right here and this big triangle right here has the same slope. So we can use the same slope nga formula. So ganitong same slope nga formula, slope 1 is equals to slope 2 and slope is equal to rise over run. So ato ta dito. Una ta sa dako nga triangle. Rise sa dako nga triangle is 6 over run sa imong dako nga triangle is 3. Di ba? And that is equal to the slope of the smaller triangle. And the height of the smaller triangle or the rise of the smaller triangle is h, and the run of the smaller triangle is x. So therefore, your height of your triangle is 6 over 3, that is 2. 2x. Okay? So therefore, this height right here is just 2x. Sige. So, ako na erase kay gubot. I hope nakasabot mo adto. Same slope. Okay, proceed. So what is the length of That one, the triangle, that is x. What is the height of the triangle? 2x. Nya, since triangle matog istorya, di man rectangle, we have to divide it by 2. Next. Plus. Napatay rectangle. Length sa rectangle, x. Height sa rectangle. Nanapunta diri, height sa rectangle. Sama na. Di ba? We knew that kaninga height diri, kaninga height is 6. Di ba? And we knew that this height is 2x. So therefore, the height of the rectangle is what? 6 minus 2x. Diba? Kaya mao man nga height ang atong gipangita niya. 6 man niya 2x. So 6 minus 2x mao na nga height. Gets? 1, 2, 3, 4. 1, 2, 3, 4. Okay, and that is equal to 0. Libog siya gamay. Then kung ganahan po mo maka-learn, then you should practice katong triangle. Because I'm just doing an equal slope adto to get the height of the cutted nga triangle. Sige, let's proceed. To i-simplify kayo, libog tan-aon. So, VA minus 9 plus x times 2x, that is 2x squared divided by 2, so x squared. Plus 6x minus 2x times x, that is 2x squared equals to 0. So therefore, simplifying this one further, you have VA is equal to 2x squared minus x squared, that is negative x squared transpose x squared, and then minus 6x plus 9. So this is your VA. Okay. Manata sa VA. How about your MA? Summation of moments about point A. Going there equals to MA plus ang kaning moment nga 9 plus 9 kilonewton meter minus 9 times x. Kani nga 9 multiplied by the moment arm of x. And then, napatay kaning triangle na punta una. Plus, sa triangle, ang base is x, ang height is 2x divided by 2, moment arm. Pila yung moment arm? 1/3 of x. Is it 1/3 of x? Kay diba, mao man eh. So, 1/3 siya kung gikan diri. Pero diri man ta nag-moment, so dapat 2/3 of x. That is 2/3 of x. Sakto? Manata sa moment sa triangle. And how about sa moment sa rectangle? Plus length of x times height of, itong height, 6 minus 2x multiplied by the moment arm of x divided by 2. Ngano ganing x divided by 2 kay rectangle man ni siya, so ang centroid sa rectangle is divided by 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so equals to 0. Simplify. Sige, laban lang. So, MA plus 9 minus 9x plus, kani siya, x times 2x. 2x squared. 2x squared divided by 2, x squared. X squared times 2 over 3x. 2 over 3x cubed. Sakto? Sunod. Plus X squared over 2, diba? X squared over 2 times 6. 3x squared. Ito. Minus x kapuya. X squared over 2 times 2x. Naglutaw na akong utok. X squared over 2. So, x squared over 2 times 2x. So, matangtang ang 2. So, that is x cubed, right? Patay ka tutaan ko. Equals to 0. So, therefore, your MADI is equal to, una ta. So, 2/3 of x cubed minus x cubed. That is negative 1/3 x cubed. X cubed over 3. So, transpose negative x cubed over 3. So, transpose x cubed over 3. Sunod, minus, gitranspose na nato, mura maning square, 3x square. Sunod, wala tayo x plus 9x. And then last, ang constant, minus 9. Oh my goodness. Okay, so this is your moment equation. Okay, so let's graph. Nakagets ra mo? I hope nakagets ra mo ha, kay libog kayo ni. Kay di man ko ka makakalkyo ani, di ba? Kay na may mga variables. Kung wa pa ni mga variables, kalkyo ra ni, oy, pastilan. Una ta sa shear diagram. Okay, so let's go. Okay, so what is your x, what is your shear if your x is 0? 9. So, let's say, so that is your 9 kuntahay. 9. What is your shear? Itapulan ako ha. If x is equal to 1. 4. 2, 4. So this is your 4. How about kung 2, 1? How about kung 3? That is 0. Sumawa lang ni mong shear. So this is your shear diagram. And take note, this one is a curve. This one is a parabolic nga curve. Let's proceed to the last one. Into the moment diagram. So, what is your x if 0? Negative 9. So, nadiridapit. How about kung 1? Negative 2.6. So, 2. Siguro. How about kung 2? 0.333. How about kung 3? 0. Sakto ba niya kung himo ang moment diagram? Feel ako dili ni sakto kay murag na pa. But anyways. So this is your moment diagram. Ay magsalig sa ko drawing because ako ra nigi butag ka ng interval nga 1 pero basin kung ato na ibutag smaller interval mas maka-define ta sa curve. Okay? But this one is a cubic nga curve. Kani, parabolic niya siya nga curve, but this one is a cubic nga curve. Unsa man di difference ng parabolic o cubic. Ang kanang parabolic kay symmetric na siya. Na siya line of symmetry. Pero ang cubic, usually, maraging ana. So, libog ang, ay, dili well-defined ang iyang pagka-curve mo ng atong cubic. Okay? So, this is basically how you are going to graph a shear and moment diagram if you have a triangular loading. And on our next example, mauni ang libog kaayo kay ato na usa ang atong mga nasabtan nga mga loadings. Lisod-lisod ni siya gamay because we have a distributed load. And naapod tay combination of triangle o rectangle dere. So, lisod-lisod ni siya. And nakalimot pa dahil kong butang dimensions. There's 2 meters. And again, our goal for this problem is to solve for the shear and moment equations and diagrams of this beam right here that is subjected to a rectangular and a triangular distributed load and a concentrated load of 8 kilonewtons. So, how are we going to solve this one? Unsa na nato buhaton? First step is to what? To account all forces, including your external forces. Don't forget about that. Kay mao dyan ay pinakauna jud buhaton. Okay? You cannot start solving if you have unknown reactions. So, instead of having this roller and this pin right here, we will make a forces nga makita na nato sila. And since kibaw man ta nga bisa nagpin na siya and kibaw ta nga nag-restrict na siya x and y components, but we can see right here that there is no x component dere, then we can just say that 0 ang imong x component sa imong pin. So, ato lang to i-cancel. And we have to solve for this is your A and this is your B. So, you have to solve for your AY and your BY. And we can only solve that one by using summation of moments. Let's say that we are going to sum the moments at point B. Summation of moments at point B is equal to AY times 2468. Di na ako magbutag unit. Mas stress na po daan eh. So, kaning atong combination at buhaton ani isa ka rectangle o isa ka triangle. So, yung ano ito, gibuhat. Rectangle and then triangle para mas dali ang ato pag-solve. So, that is, una ta sa triangle, positive, negative, minus, kay it creates a counterclockwise and we assume clockwise direction. So, that is 5 kilonewtons per meter times length of 2. Diba? 2 meters naman na siya and divided by 2. Next, minus kay sa rectangle pod ta. That is length of 4 meters, height of 5 kilonewton per meter. Di na ta mag-divided by 2 kay rectangle man ni siya. And oh no, napaday tayo, moment arm. Pila ang moment arm ani niya? Sa aning atong triangle. Diba, naama na dira ang iyang centroid and that is 1/3 sa atong 2. From here, that is 2/3. So, unsay 2/3 sa atong 2? 1.3333. So, 2, 4, 6. 6 plus 1.333. 6 plus 1.3. 7.333 na lang. Okay? Moment arm. And then, moment arm po ani. So, unsay moment arm ani? Diba, ang centroid sa itong rectangle kis tunga man. So, 2, 4, 6. So, that is 6. Naputay 8. Naputay 8 kilonewtons. So, that is minus 8 kilonewtons times 2 equals to 0. So, therefore, your AY is 21.583 kilonewtons. Okay? Support reactions pa ta ha? Layo pa ta. So, tip. Tip ta. Pwede rin mo dili isolve ang BY. Kung magsugod ka dili sa left. And sa atong mga problems karon, we will always start at the left. So, I would highly suggest if you have a support reaction, it's best if you are going to solve for the left nga support. Okay, para di na ka mag-solve sa right. Kay inikat-kat na to later, di man ni siya magpakita. Okay, so kanila ito solve. And that is 21.583 kilonewtons. Okay? Now, let's proceed. Second step, we already have solved for the support reaction. Ang AY lang again because we don't need BY. Okay, di man siya ma-apply sa atong pagkat-cut later. So, ang next step, unsay ato buhaton next step, di ba? Ato pangitaon kung asa ta mag-segment, di ba? So, question, pila ka buok segments ani? Di ba, makaingon ta nga mag-segment rata kung na-i change sa slope sa loading or na-i change sa loading. So, inigtanaw ni mo aning atong distributed load. Lahi siya og slope sa ani. Kay zero slope man eh. So, paingana. So, we have to segment here. And this is your segment 1. Kanina po siya, constant ang iyang slope dira, pero nawa na po og load diri nga part. So, this is your segment 2. And wala man siya loading diri, pero naa kay concentrated force diri of 8 kilonewtons, that is your segment 3. And wala na pud kay load diri until dira, that is your segment 4. So in this problem, you should have to create 4 pairs of shear and moment equations. So let's first go with our first segment. Sa ato buhaton, kung ato na to sa first segment, magtunga na punta diha sa atong segment. And then ato ibutang ang distance as x. Diba? So, let's say, nagtunga ta dira, and that is the distance of x from the leftmost portion of this beam. Sige, so, let's make a free body diagram. So, mo ni atong gitunga diri. Mo ni katong blue, kani. And, ang distance ani is x. Okay? This is where the challenge starts. Okay, diba? We already knew that this one, you can consider this one as a triangle, and you can consider this one as a rectangle. And the height right here is the challenge. So, ano ito pagkibawaan ng height? Di ba kaninga triangle kay ingana man ta na siya? And that is your 2 meters. Pero nag-cut man ta dira. And mo na itong x. So, mo na itong x, pila naman nga height. We can use equal slopes. So, di ba kay kibaw man ta nga height? Katong 2 meters na siya. 2 meters na siya. And then, we know that this one is 10. And we know that this one is 5. So, basically, this one is 5. 5 kilonewton per meter. And this one is 2. So, therefore, rise over 1 is equal to rise, which is, we don't know. Let's just say W over X. So, therefore, your W right here is equal to 5 over 2x. Okay? So, this is 5 over 2x. Ang kani lang na ha, ang kani. Ang kana ang height. And kani nga height, pila man siyang height? That is 10 minus 5 over 2x. Gets? I hope you did ha. I-0.5 ang speed sa akong lecture para makasabot mo kung naglibog mo. So let's proceed. And then we still have this 21.583 kilonewtons. And now, let's solve for VA. To get VA, all you have to do is to sum the forces along the Y, going down, is equal to VA minus 21.583 kilonewtons going down plus triangle taon na. Pilay height? 5 over 2x. Muna'y height. Ang length, x, sakto, di ba? And then, 0.5, kaya di ba triangle na siya? Height times length times 0.5 para makuha nimo ang resultant sa triangle. Next, plus, kaning length, kani siya. That is, length of x times height of 10 minus 5 over 2x. Mura pa na siya? And that is equal to 0. Di na ko mag 1, 2, 3, 4. So let's simplify this one. Ayaw ko yung nangawa ni na record ha. Ayaw ko yung nangawa ni na record kaya na-stressed pa ko solve. Ay, salamat. This is VA minus 21.583 plus, di ba, this is 1/2. 1/2 times 5 over 2, that is 5 over 4 x squared plus 10x minus 5 over 2x squared equals to 0. 5 over 4 minus 5 over 2. Hindi na ako mag-fraction. So, to simplify this one further, that is VA is equal minus 21.583. So, kani sila masimplify man nimo. And ang answer niya is negative 5 over 4 x squared plus 10x. So therefore, simplifying this one further, we have VA is equal to 5 over 4 x squared minus 10x plus 21.583. Guys, diri ra nilisod kay triangle mangguni siya. Later, di na ta maglisod later. Okay, I promise. Okay, let's proceed. So, mao ni atong equations atong first segment. Okay? Okay. So, moment. Let's do moments. So, same. We are going to sum the moments about point A, which is this one. Okay? And let's assume the direction is counterclockwise. That is MA minus 21.583, and that moment arm is X. Sakto? Then, diri na pod kani sa triangle, plus base, which is X, height, which is 5 over 2, X, and then half, 0.5, and then moment arm, pilay moment arm ani, di ba? Ang moment arm from here is 2/3 X, so that is 2/3 of X. So this is your X, and we're looking for the 2/3 of this X. Cubic na ta. Laban. Next is plus. Sa rectangle na punta. Rectangle, base is X, height is 10 minus 5 over 2X. And then, moment arm of, di ba? Ang moment arm sa rectangle, tunga. So, that is X over 2. 1, 2, 3, 4. 1, 2, 3, 4. And all of this is equal to 0. So, simplify again. That is MA minus 21.583X plus 5 over 6. So, ako rin nag-calculate ha? Kaning tulo. 5 over 6 X cube. Sakto? Plus 10X minus 5 over 2 X squared times X over 2. And this one can be simplified further as 5X squared minus 5 over 4 times X cube. Let's proceed. So therefore, simplifying it further again, MA minus 21.583 583x negative 5 over 12. 5 over 12 x cubed plus 5x squared equals to 0. Whew. So therefore, simplifying it further, you have MA is equal to 5 over 12 x to the 3 plus 5x squared. Oh no, this is minus 5x squared plus 21.583x. So, this is our MA. Wait, this is killing us. This is too much. Okay, so we're now finished on our first segment. So, this is our first segment pa lang. Don't worry, kay ani mo po na itong mga exam. Okay, so ako na ibutang sa ako summary. So that is our first segment. Second segment na ta. Yay. Diba? Segmento ato ra gihapon bahaton magkataaning tunga ani unya ato ibutang ang arbitrary distance as x. And we have to draw the free body diagram. So ang free body diagram ana niya mahitabo. Now, how are we going to solve this one? This will be much easier compared sa atong triangle kaganiha. Kalitan tatong triangle kay lisod man gadyo ng triangle pod noon. Pero ingato lang ang concept. Okay? Sige. So let's solve first for the VB. To get VB, sum the forces along the y going down is equal to VB minus 21.583. Sige, let's use this triangle na lang to make it easier. Pila man na siya nga triangle. We know that this is 5 and we already know that this is 2. Kaya na-cover naman ang iyang whole nga length. So, base is 2 meters times 5 times 0.5, right? Suma na ang sa tong triangle. And that is plus. And plus na punta, kanina pong rectangle nga dako. So, pila man na siya. Base is x. Height is 5, right? And, lang to. So, 1, 2, 3, 4. 1, 2, 3, 4. So, equals to 0. And basically, here, we'll find out that your VB is equal to negative 5x plus 16.583. Ano mo VB? And I think ang atong MB is negative 2.5x squared plus 16.583x. Muna akong i-expect nga value sa atong MB. Let's check. Okay. So, summation of moments at point B is equal to MB minus 21.583x plus, sa triangle ta, base of 2 times height of 5 times 0.5, and then moment arm is, ang moment arm ani, diba, x man ni siya, and then naadiri ang centroid. So, what is 1/3 of 2? Diba ka ang 1/3 of 2 is 0.66667. So, ato baton ana is x minus 0.667. Ano man? Kay diba mo aning length sa x, and then ang distance na to nga goal kay from this point to this point. Diba? And then this distance here is 0.67. So that is why x minus 0.67 para makuha na tong moment arm sa atong triangle. Gets? Next is plus. Sa rectangle na punta, base is x times height of 5 times moment arm of x over 2. It's equal to 0. Okay. Simplify. MB minus 21.583x plus, ay, kakapoy eh. 0.5 times 2, 1, 5. So that is 5x minus 3.33. Next is plus 5 over 2x squared is equal to 0. Simplify this one further. MB minus 16.583 x plus 5 over 2 x squared minus 3.333 equal to 0. Therefore, your MB is equal to negative 5 over 2 x squared plus 16.583 x plus 3.333. Close enough. Wala lang ko 3.333. Okay, constant man na siya. Basta. Humanata sa segment number 2. Oh my gosh. Ito na po nibutang sa atong mahiwagang summary. So, let's go to our third segment. Ano ito yung naghihingalo na taning kalakiha. So, free body diagram na po ta. Kapoy no, kapoy. Nagtanaw ra mo, ako dapat amo ingog kapoy. Sige. So, ato na pud baton, maghimo na pud tagkat dira. And then, assume na pud nato, ang distance is x. Okay. So, ang atong buhaton is same gapon. Dito nagkat ha. Then, that one. Okay. And again, this one is 21.583 and this one is VC and MC. Let's do this. So, summation of forces along the Y going down is equal to VC minus 21.583 plus triangle gihapon rectangle. So, kibaw naman ta sa base. Base is 2, height is 5 times 0.5. Ang sa rectangle, base is, kibaw na ta sa base kay wala na siya natunga dire. Di na tong x. So, pila ng base karon? That is 4. Height of 5. Dili ta mag 0.5 kay this is a rectangle. Okay? And equals to 0. So, therefore, your VCDI is equal to. So, as you can see, constant na itong VC. Kay wala man tayo loading diha. Kung na tayo loading diha, then ato tayo variable ng x. So, your VC is 3.417. So, we have our VC as 3.417. And as you can see, this one is a constant value. So, straight line na siya. Wala na tayo problema. Okay, next. How about our MC? I'm sure this is x na siya. 3.417x and then apa na idugang. Summation of moments at point C going there is equal to MC minus 21.583 times x. Diba? Kay x man ni. Ito. Sunod. Plus base of 2 times height of 5 times 0.5 times moment arm of x minus 0.667. Diba? Okay, x minus 0.667. Padayon ta. Plus base of 4 times height of 5 moment arm. That is x minus, di ba kay 4 man ang length ani. So, tunga ana 2. So, that is x minus 2. Okay, di ba? Direct ang moment. And then, 4, 2. So, ang distance ani, mo na x minus 2. Okay, 2 man ni siya. 1, 2, 3, 4. So, equals to 0. MC minus 21.583 x plus 5x minus 0.333 plus 20x minus 40 equals to 0. So that is MC is equal to, this is 3.417x plus 43.333. Kapoy na. This is suffering, okay? Okay. Dita, segment 3. 3. Ano? Last. So let's go to the fourth segment. Same gihapon na atong paagi, atong gihapon na i-cut. So, okay, let's solve for VD. Summation of forces along the Y going down is equal to VD minus 21.583 plus same base of 2 times height of 5 times 0.5 plus base of 4 times height of 5. Naputay 8, so plus 8 is equal to 0. So therefore, your VD is now equal to negative 11.417. Okay, 11.417. So, last. Summation of moments at point D. Going there is equal to MD minus 21.583 x plus 2 times 5 times 0.5 moment arm of x minus 0.667 plus 4 times 5 times moment arm of x minus 2 and then patay 8. So kanang 8. So man na plus 8 times the moment arm of x minus 6 equals to 0. So MD minus 21.583 plus 5x minus 3.333 plus 20. So that is 20x minus 40. Sunod plus 8x minus 8, 16, 24, 32, 40, 48. 48 is equal to 0. I don't like this anymore. So, MD, 5 plus 20, 25. 25 plus 8, 30. Hoy! May lagi value. Ano wala man diri? Ano ko? Dapat mo na X. Ay, salamat. So, plus 11.417 x negative 91.333 is equal to 0. So, your MD is equal to negative 11.417 x plus 91.333. Manata. Pero wala pa ta naman kay mag-graph pa ta. 3, 3, 3. So, we already have our shear and moment equations on each segment. Segments 1, 2, 3, and 4. And as you can observe, the hardest of those segments that we have dealt with is katong na a triangle. And basically, that is the hardest jod, ang triangle nga loading. Di na ta mo dwell og kanang parabolic nga loading because we are going to be stressed with that one. Okay? So, kutob lang jud tag triangular nga loading. Okay. Now, let us graph. We're not yet done because we have to graph this one. Okay, so how are we going to graph that one? So let's first go to our shear diagram. And then we all knew that the whole length of this beam is 8. So let's divide it into by 2. 0, 2, 4, 6, 8. Okay? So start as a segment 1. Ngit-ngit, I can see. If your x is 0, what is the value of your shear? That is, of course, 21.583. So, ato ibutang, let's say this one is 21.583. And how about kung 1? Di ba? 1 man ni siya. Di ba? If x is equals to 1, your value will be somewhere at 12. So, let's say siguro this is your 12. 12.833. 12.833. And how about kung x is 2? Your answer is 6.583. So that is 6.583. Somewhere right there. 6.583. So ako pa ninyo mag-graph mo og tarong kay kani akong graph estimate ra jud ni ayaw mong panundong nako. Humanata, kutob tuto. So this is from 0 to 2. And this one is 2 to 4. Okay? So diri na punta, proceed na ta diri. Dira na punta ang equation. And if your x is equal to 2, what will be the value of your 1? So that is still 6.583. So as you can see, kani siya is parabolic. Pahingana na siya. Pa-curve. Ang imong first nga segment. Okay? So sige, so 6.583 gyapon na siya diri sa atong if x is equal to 2. Since we already know nga di man siya squared, kibawta nga linear ni siya. So kung makahibaw ka nga linear, diretso na lang ka sa end sa segment na niya, which is dito sa 4. So pila yung value niya kung 4? 3.417, and that is negative. So negative 3.417. So linear na siya pa ubos. Wani klaro akong graph ha. So mas mayog himuan ninyo yung tarong nga graph. Okay. So line ni siya kani kay curve, parabolic. Okay. So segment 3 ta. Imong segment 3 from 4 to 6. So ato lang i-confirm. Okay, so there is a correction. I found out that this one is negative. Okay? So sakto atong kuan diri nga constant na siya until sa end sa segment 3. That is horizontal line. Let's proceed to segment number 4. That is negative 11.417. So basically, it will start here, negative 11.417, and it will end here. Again, because this is a horizontal line. Kay constant ang value. So basically, this is your shear diagram for this beam. Hay, kasamok lamok. Okay, let's proceed to the moment diagram. So, lisod-lisod na dyan ni siya. Well, dili mo siya lisod kay igo ra man ka mag-graph, no? Pero weird lang. What is MA if x is equal to 0? Of course, 0 ang imong value. If x is equal to 1, kita diri is 16 point, so basically that is 17. Kay 16.999. So let's say, so sa 1 kay 17, sa 2 kay 26.5, 26.5, yan akong tahay. So sa 0 kay 0 ha. And then, so humanata sa 0 to 2. So proceed ta sa sunod. If x is equal to 2. Tuloy confirm. Sakto gyapon 26. So this is 26.5. This is 17. 26.5. So sakto. How about if x is equal to 3? 30.582. So ano siya diri? 30.582. So ganing nahitabo. Kani siya cubic ni siya nga curve. Kaya as you can see, ang kani nga equation cube. So cubic na iyang curve. So the value here is 30.580. And if inyo na susihon ng pagmaayo, curve na po na siya. Okay? Pero karon, how about, no. Okay, so let's proceed. How about if your x, imong x, 1, 2, 3, 4. If your x is equal to 4, your answer is 29.653. So, niubos siya. 29.653. Okay? So, yung anak kong tayo ayan na hitabo. Pero, I'm not sure with the curve haba. Basta kibaw ko nga curve na siya, pero di ko kibaw kung yung ano dyan iyang behavior. Okay? So, muna. Let's proceed. Dirita sa segment 3. So, segment 3 ta, solve if your x is equal to 4, almost the same. As you can see, this equation is a linear equation. So, line ito himon. So, pwede na ta again magdiretso padong sa end. And that is 6. So, solve for x is 6. That is 22.831. And I think 22 is right here. Okay? So, diretso. 22.831. 22.831. And then, dito ta sa segment 4. Negative 11.417 x plus 91.333. So, 6x 8. So, 22.831. So, sakto. And then, how about kung 8? That is 0. So, and this is your moment diagram. Always take note. Always dyan na siya dapat mabalik og 0. Kani siya, ang values kani og kani, mao ni sila actually ang imong support reactions. 21.583 diri kay 11.417. Okay? And then diri dapat gyapon na siya mabalik og 0. So, therefore your maximum shear diri is pila man. As you can see, compare niyo mo 11.417 and 21.583, of course that is 21.583 ang maximum. How about ang maximum moment? Can you tell nga ang imong maximum moment is 30.582? No, you cannot tell that one because probably right here na mas higher nga value ana niya. And I'm sure that there is. Why? Ano makasulti ko ana? Kay this is a fact that your maximum moment is always located when your shear is 0. So asa man 0 ang imong shear, asya diri. And therefore your maximum moment is located somewhere right there. And how can you determine for your maximum moment? Unsa ni siya nga segment diri? This is your segment number 2. Let's go to segment number 2. And ang ato buhaton, ato ilocate ang x kung asa dapat mag-0 ang shear. Okay? So, ato buhaton is gi-0 ni nako, ang VB gi-0 nako, and then equals to negative 5x plus 16.583. Para makuha nako ang x. And kanang x mo ng distance kung asa na dapat imo maximum moment. And we'll use that one to solve for the maximum moment. Sige. So, and that is 3.32 meters. So, 3.32 meters, dira na-locate ang imong maximum moment. Okay? So, therefore, substitute that one there. Your highest value of your moment or your Mmax is, again, ako na nag-substitute sa x diri. Na 30.882 kilonewton meter. So, ing anak. Gamay na siya ligas, no? Pero, mao ni maximum. Almost maximum. Kaya ato naman nag-round off ang 3.32. So basin napadyoy mas closer ana, pero this is close, very close compared sa imo 30.582. Lisod no, taas kaayo, taas na siya kayo, legit. And I hope nga bisag taas ni siya, you still understood. And I hope wala mo nawan ang gana sa pagpaminaw. So, yon. By this concept that I've taught you, you'll be able to solve for the shear and moment equations of a beam that is subjected to several loads. And by these equations, we can create the diagram later. Okay? And on the next meeting, I will give you some techniques on how to easily solve this one by using different strategies. Because na ay shortcut ani. Okay? And by just looking at the relationship of your shear and moment, you can see na nasa a relationship. Okay, so nga na. So as a summary for this lesson, you already know how to create a shear and moment equation, and you also knew how to graph a shear and moment diagram. Okay? So, thank you for listening, and I hope that you understood our lesson. And if you did not understand our lesson well, then there are a lot of examples in the internet and on our reference, then you're good to go. So, thank you for listening, and see you again next week.